High-altitude balloons, often called weather balloons, have gained popularity due to new technology, putting perspective on the journeys that these balloons make. But devices like this have been used for years as a science tool.
The high-altitude balloon is a good instrument for doing research.
From weather pattern studies to actually attaching satellite components to test in space. The costs are extremely minimal in comparison to other methods.
Gets you to places that are relatively, you can't really easily put a satellite to orbit in that area. Gives access all the way from, the Earth's surface all the way up to near space, where 1% of the atmosphere.
The basic rig consists of a large latex balloon filled with hydrogen or helium, GPS tracking systems with real-time location updates, and a parachute. The rest is up to the scientist. Experiments and devices are attached to the balloon and secured by tether and carabiner. Instruments can vary, and so can weight. Scientists record the weight of the payload and calculate. Through a formula, scientists can make accurate projections of the flight path. This gives the chase team an estimate as to where the balloon will land.
What's the next crossroad?
As it travels over 100,000 feet up into near space and back down. Many times only a few miles from the launch site. On its way up, the balloon travels through various types of atmospheric activity, all the way up into near space. Attached experimentation and equipment experience many different temperatures and pressures. As the balloon rises up and the atmospheric pressure decreases, the gas inside the balloon is expanded. Eventually, the expansion is too great for the latex to hold. The balloon explodes, sending it tumbling back toward Earth. The attached parachute helps to slow the fall. Ground teams monitoring the balloon's position spring into action with the goal of visually spotting the balloon before it hits the ground. They are always hoping for an easy find. In Indiana, Taylor University is well known in the world of high-altitude balloons. Dr. Takahara, Jeff Daly, and Jason Kruger organize a yearly camp for young scientists interested in aerospace sciences.
Well, it's our young people that are our future.
There you go.
And you need to get them when they're young.
We want to create learning experiences that are hands-on, that focus on STEM, science, technology, engineering, math, and really give those to students at all age levels so that they can hopefully pursue a career and help our country develop in technology and industry.
Here the kids make their own predictions, conduct experiments, and launch their own balloon in an effort to inspire them and keep them interested in pursuing scientific investigation. Science
is about doing. It's not about just reading about it or watching a video. It's getting dirty, getting your hands dirty. It's about seeing things happen and working right in front of your eyes and learning through experience.
Nearby at Marion High School, an AP chemistry class has taken this idea to the next level. partnering with Takahara to launch a balloon with their own experiments as a class project. Experiments include testing sunscreen, trying to liquefy a gas, and even a test to determine the best space meat.
We're going to have one steak exposed to the atmosphere because it's less dense up there, and the temperature, and then we're going to have one that's just frozen, and then we're going to have one strapped to the side of this so that it gets hit by the UV radiation, and then we're going to have a control, and then we're going to take them all back here and see which one's the most delicious.
Activities like this can be a defining moment for young scientists. It might be that spark that ignites the interest for someone to change the world.